are only defined in radians. So when we want to use inverse trig functions in our calculator needs to be in radian mode. Up here it should say, or if you hit the mode button, remember it's the third option unless you switch back and forth. But inverse trig only exists in radians, so it should not be in degrees at all. Well, the calculator can be a little tricky. There's a couple things that work great, a couple things that can work fine if you know one thing, and then one inverse trig function is kind of tricky with how we have to put it in the calculator. So the first three that just work, you don't have to question what you're doing. As long as you're in radian mode, inverse sine, inverse cosine, inverse tangent, these all just work as intended because your calculator have these things programmed in. So to get inverse sine, just hit second sine. For inverse cosine, second cosine. And for inverse tangent, second tangent. I think I got those typed in correctly. But make sure that you throw them in your calculator and see that you're getting the same values before we go on. Okay, everybody okay with where those came from? Okay, now let's say we tried to throw this one in here. Inverse cosine basically has its own button in the calculator. So company that makes your calculators have those programmed in correctly. But on this one, if you ask your calculator what's inverse cosine of 1.5, it's going to have a problem with this. It's going to give you an error message. Now notice when you get an error, it tries to give you a hint here. Something's wrong with the domain. So what is the domain of inverse cosine?
-1 to 1.
So if the domain is -1 to 1, so us math teachers, we don't just ask about domain and range just because we particularly like it or because it's just something we want to see if you can do. It's a way to make sense of this stuff. Domain is the values that you can plug in. So if you're trying to plug in a number bigger than 1, it doesn't make sense. You try to plug in a number smaller than -1, for that function it doesn't make sense. So your calculator tries to warn you about that by saying error domain. But I will tell you, I always say this every year, and then, well, we don't always give the same test every year, but there is one test that we give sometimes, or some questions that we give sometimes. And there's a question like this on our test, which of course is a few weeks away. And every class there'll be 2, 3, 4, 5 people come up and say, I think my calculator's not working. And it's not that your calculator's not working, it's just that you can't do it. And I can't give you that kind of hint on a test. That's testing if you know what you're doing there. So your calculator can do these just fine as long as the numbers make sense. Yeah.
So you say like no solution?
Yeah, not possible, undefined, but if you're asked why, you really need to refer to domain. That's the why. Okay, so we've got those three that just work, and then secant, inverse cosecant, and inverse secant are not too bad, but there is one extra little step that we have to be careful about. And the problem becomes where these are just not common enough that your calculator company makes a button for these. So your calculator has not been programmed to just handle these unless you have like a TI Inspire, which I don't really like TI Inspire, so I'm not trying to convince you to get one. But they do have a trig button that has all these pre-programmed, so that's kind of nice. But we can use some of our trig identities. So since secant is the reciprocal of sine, the most common way, and I want you to write this down, that people try to do this is like this. But you need to put an X through that. That is not how you do that. Remember that inverse functions give you an angle. So if I do 1 over an angle, that's the reciprocal angle. And I can't think of a single time in mathematics I ever needed a reciprocal angle. What we need is the reciprocal ratio. So reciprocal trig function, and this guy is the ratio. So as long as you do the reciprocal of the right piece, and you know sine is the reciprocal of cosecant, now our calculator can do this just fine. You don't need to type this one in. I'll have you try the last couple. But this one comes out to be about that. Okay, again, don't do this. This would be the reciprocal angle, which is not what we want. So put a big X through it. We need the reciprocal ratio, and in inverse functions, the ratio is the thing that gets plugged in, is the input. Push. But beyond that, what the calculator says, we do not have to second guess that. Okay, I'd like you to write out the next two, what you think should go in the calculator, and then type them in if you think you need to. And then I'll give you a little bit of a head start, and then we'll make sure that we're all on the same page. Okay, is that long enough for y'all to put these in? Okay, so for this one, did you actually type that in your calculator? Why not? It's going to be not infinite. Oh, okay. You can't divide by 0. So I don't know what error message your calculator is going to say. So you can say not possible or undefined would be fine. But you can't divide by 0. So I suspect that if you type that in, your calculator probably said error division by 0. There's no angle that has a cosecant of 0. So that's what it's trying to tell you, but it can't just come out and say that in a sentence. That's the closest your calculator can do. And then this one, 0.742. Okay with that? Okay, so of course this is just my theory. I don't know. But when they make these calculators, you know, they only put so much memory on them, so many buttons on them. And so inverse sine, inverse cosine, inverse tangent just come up much more frequently. Those even come up in geometry classes, probably on the ACT. But then they probably don't share their memory or don't want to use their memory for these, because if you need these, there's a good chance that you know sine is the reciprocal of cosecant, and you should probably understand that it's the reciprocal ratio. So I think that's why they don't bother to put that in these calculators. But someday, 20 years from now, when everything's cheaper and it costs them nothing to do it, then they probably will. But all right, which leads us to inverse cotangent. So we've got the first three that just work. These work out fine as long as we're careful about how we type them in the calculator. And our calculators don't have an inverse cotangent button. So what I would hope you would assume is that you would do inverse tangent of the reciprocal just like we did above. And if you put this in your calculators, you get answers like 0.197, 0.400, negative 0.124, .081, negative 0.259. All of these questions look about the same. What I'm typing in the calculator basically looks the same. None of the answers really stand out as being different. But 3 of these are correct and 2 of these are not correct. And this is where inverse cotangent's the trickiest of all of them. And it's not that our calculator is doing anything wrong either, by the way. And it's also not that I have done anything wrong to this point either. So any guesses on which 2 might be wrong? The negative ones? You are correct. So if it's inverse cotangent of something positive, what your calculator gives you is the correct answer. But if it's inverse cotangent of something negative, we still have to do that, but this is not our final answer. So this part's really hard to figure out why. But does anyone have an idea why these 3 would be right and those 2 would be wrong? Like, what's wrong about doing inverse cotangent of something negative? Okay.
Oh, is it like 0 to pi? Just the range means, so it should be below 0.
Okay, so the range of inverse cotangent is 0 to pi, correct? So what's wrong about what we're typing in on these questions? What's the range of inverse tangent? And then this is why it's a problem. So if you ask your calculator, or if you want to know this, you type it in the calculator this way, and what you're asking your calculator is, hey, where's there an angle that has a tangent of 1/5? And since this is positive, it finds an angle in quadrant 1, about right here, and it says, hey, it's right there. And that's not a problem because inverse cotangent and inverse tangent both exist in quadrant 1. The problem occurs when you try to do inverse cotangent of something negative. The best way you can type it in your calculator is by doing inverse tangent. But again, your calculator doesn't know what you're trying to do with this. So your calculator is doing this correctly. You're asking your calculator, hey, where's there an angle that has a tangent of negative 1/8? And it finds that for you. It's right here close to 0, but negative. Right here close to 0, but negative. And that's great for an inverse tangent answer. And that's what I asked it, but what I really want is inverse cotangent. And my calculator doesn't know that that's how I want to use it. So we do have one thing going for us. It's not hard to get the final answer here, by the way. I'm just trying to help you see why your calculator is wrong sometimes and right sometimes. At least with tangent values, they're kind of a pain to work with, but if you know some angle has a certain tangent value, directly across the circle is going to have the same tangent value. So I'm right here in quadrant 4 on those 2 questions, but I want to be over here in quadrant 2. So how do I get from here to here? If I add 2 pi, I go all the way around.
Oh, okay, just one.
Right, you want to swing halfway around the circle, so you have to add pi. Add pi. before you get your final answer. So this one is actually 2.883. And this one is 3.017. So you can sum that up to yourself pretty quickly. The only time you add pi to what the calculator says is if you're doing inverse cotangent of something negative. All the other ones don't need that. If it's inverse cotangent of something positive, it gives you an answer in quadrant 1, which is fine. But if it's inverse cotangent of something negative, you have to add pi to get the correct answer. Now again, I went through all that so that you can understand why, so hopefully it sticks with you a little bit longer. But for the sake of your quiz and your test, I would probably write that out in a sentence at the top of your page so that you can quickly look at that and review
Can I
it.
switch?